Alright, welcome back everybody, and today we're going to be doing question 2 of the 2018 Methods Exam 2 using CAS programs. And as you can see by the length of this video, this 10 marker right here really doesn't take too long to get through, especially if you use the CAS programs in the right way. So I'm going to start the timer and we'll just jump straight into it. So let's go. So the first thing we have right here is this function b of t, and I should mention as well I'm in my exam document right here, the methods exam document, because everything's nice and accessible through this var button right here. So we're going to go to menu 1.1 to define our b of t to be equal to 4500 over 7 times brackets e to the minus t over 5 minus e to the minus 90 over 10. So that's our function b of t, and right here in part A it says find the time. So our t right here in hours it takes for drug X to reach a maximum amount, and the maximum, well, that's just a stationary point local maximum, so that just screams for analyze. So we're going to go to analyze our function b of t with respect to t. Press enter, add domain, don't really need one, so we're going to put a 0, and then it's going to spit out all this information to us. We're going to scroll down to stationary point, which is what we want, and as you can see the t value in this case is 10/7, natural log of 9 halves, and this is a 2 marker, so you need to show a little bit of working out. We can just say b prime of t, well, your derivative is given right here, which is minus 450 over 7 e to the minus 90 over 10, and then 2 e to the 70 over 10 minus 9, and we want to solve for where that equals 0, and of course that's your answer right there. So that should be enough to give you the 2 marks. Okay, and the graph of b of t is shown here, and we need to find now the average rate of change. That's nice because there's a program for average rate of change. If you go to the catalog menu right here, go down to methods differential calculus, go to average change, we want to put down our function b of t, our variable t, and then we need the lower and upper bounds, which is 2 and 6, like so. Enter, and it's going to give us this. We don't really want that. This is approximate to 1 decimal place, so we're going to go control enter. It's going to give us this, and then we can just write equals minus 33.5 because that's rounded to 1 decimal place. Of course this is a 2 marker, so you do need to show working out once again. We can just use the average change formula. You should probably have it in your bounds reference, which is b of 6 minus b of 2 over the length of this interval, which is 4. So that's 4 marks in 2.5 minutes. Let's keep going. Find the average amount. So this is the average value of a function. So if you go down to methods integral calculus, there's your function average right there, and then we're going to put in our b of t again. B of t, comma your variable, which is t, and comma your lower and upper bounds. It says during the first 6 hours, so that implies that you're going from 0 to 6. Enter. You get all this junk again, but it wants nearest milligram, so let's go control enter. It's going to give us 255 to the nearest milligram. That's 256 because we have 255.85, so rounding it up, 256 milligrams, and of course again 2 marks, so you do need to show a bit of working out. So it's just 1 over the length of that interval, which is 0 to 6, so 6 times the integral from 0 to 6 of b of t dt. That should give you your answer, so that's another 2 marks right there. Next question, part D, don't really need a CAS for this. You need to sketch the total amount of drug X. So you have kind of your first intake right here, and then your second intake, and to find the total amount, it's just adding these 2 graphs together. And of course for your second intake, everywhere before 6 right here is 0, so it's just addition of ordinates. So if you want to graph it, of course for the first intake it's just going to match exactly what you have for tablet 1, but at 6 hours right here, that's when you start to have the second tablet. So if you kind of add this curve onto what we have already over here, you're going to get something that looks like this. And of course you do need to be a little bit careful about where this maximum is. I don't know if VCAR are going to be too picky about that, but what you can do to figure out what the maximum on the second intake is, you can go to analyze, and then b of t, that's your first intake, plus your second intake, but it's shifted over by 6, so b of t plus b of t minus 6. That is a translation to the right by 6, comma t. You can analyze that, no domain, and that's not really helpful. It's just giving us a bunch of random stuff, so let's control enter, no domain. And then now, there we go, we have 7.779, which is right around here. 455, so let's guess somewhere around here. So we kind of want our maximum to line up right over there. And then, of course, it's going to come down again. So that's the general shape of the graph. You can use the analyze program to kind of approximate where this maximum will be. So that's part DI done. Now for part DII, find the maximum amount of drug, which is this peak right here in the bloodstream in the first 12 hours. Luckily, we've already done it right here. So time, so t equals 7 now this is 2 decimal places, so 7.78. And then b is going to be at that time, it's going to be this coordinate right here, or this y coordinate, so 455.82. It's 2 marks. You probably need to show some working out, so you can say let's the derivative of b of t plus b of t minus 6, that's literally what you put into your CAS for the analyze function, b equal to 0, and then t equals this, and then b equals that, and you're done. That's 10 marks in 6.5 minutes, and on top of that, I also had to explain what I was doing. So if I were to do this question, it would probably only take 5 minutes. So yeah, there you go. 10 marker in 5 minutes. It's doable for questions like this where you can rely on your CAS programs. So yeah, that's pretty much it for this video. I hope you guys enjoyed it, and I'll see everyone in the next one.